Whether you're checking your email for work or connecting with friends, confidence in the security of your mobile device and data is critical. With so much at stake, it's important to find a platform you can rely on to keep your information safe. And as threats evolve and grow, you need an OS that gets better, smarter, and more resilient over time. How do you make the right choice and know you're selecting a platform that is equipped for all the challenges that lie ahead? In this video, you'll hear from leading industry experts, Gartner analyst Patrick Havasi and Google Vice President of Security, Dave Kleidermacher, about the state of mobile security and how Android is working to protect billions of users.
Yeah, today we're seeing the growth of attacks on mobile devices. You know, in the past we've had endpoints that we've been protecting, laptops, desktops. We've put antivirus and advanced solutions on those. But now, as the mobile devices are the kind of the primary use cases for the employees inside the enterprise, the tablets, the phones, the slates, the Chromebooks, and things like that, we are also starting to see more advanced attacks moving to them. At the beginning, when mobile attacks first kind of started, they were more about consumers. There was a lot of attacks that were trying to phish your SMS passcodes for your banks and things like that, or sending premium SMS messages and charging like a penny, and you'd never see that on your bill. But now, as this is the primary carrier of devices in the enterprise for a lot of organizations, we're seeing these advanced attacks, Trojans on there. They're trying to sniff your network as you go into the corporate headquarters. You know, you go into an airport, you go into a coffee shop. Do you really know that you're on the real Wi-Fi, or is there a hacker actually looking at it? And then as we go into the applications as well, thinking about the applications that are installed on these devices, they're asking for all these types of permissions as well. And then we get into the vulnerabilities of the devices as well. We've seen Blueborn as an example of an attack last year where they found a compromise of the Bluetooth stack. We've seen named attacks like Pegasus that actually targeted and got low-level permission on iOS and Android. We've seen rooting attempts. We've seen people trying to steal developer certificates and write these malicious apps. And now IT and security has to not only think about, I have to defend from all these types of attacks that have been on my desktop and endpoint before, but now the mobile devices as well. It's a full-fledged endpoint. I need to start looking at a secure device, a secure operating system, and even possibly looking at mobile threat defense or some kind of advanced malware type solution on mobile devices. And this is not to say that the mobile world and attacks are overrunning your desktop and PCs. This is just to make you aware, right? You have to start thinking about, I'm going to have to protect these devices. I'm going to have to look for these solutions. I mean, and they did start with the attackers really started targeting the consumers, right? I want to get you to download something. I want to steal your information. I want to then start, phishing you and doing things like that. We've just recently started to see exploits coming in toward the business world. So the sky is not falling, but it is something to start thinking about as you evolve your entire endpoint protection strategy. You need to start thinking about, well, what kind of information is on my device? What would be critical as a CISO to protect on that mobile device? Yeah, Android, since KitKat version 4.0, has really grown a lot from a security perspective. It really started off, kind of focusing on consumer, but then started adding some security features. They took the secure Linux kernel, which was the basis for the Android operating system, and hardened it. So they took the challenges that we were facing on the PCs and endpoints and looked at it and how do we develop a more secure operating system for the mobile device, locking things down. So enforcing the secure Linux into the version 5.0. In Android 5.0, they introduced Android for Work, and now named Android Enterprise, that allowed organizations to have a separate work profile for their users, right? So then storing their docs and applications into this secured container format. As they continued to evolve, they created the Google Play Protect, which was a set of security controls that integrated with the Google Play Store and looked to try to protect the applications these unwanted applications, these malicious applications. And then they started opening it up to third-party security companies as well, like the mobile threat defense companies, to plug into the Google Protect API to add even more capabilities. Then they started looking at the hardware and the software. How do we make sure that the phone is booting up with the right operating system through hardware integration through the TEE, or the Trusted Execution Environment? So putting certificates and storing hashes inside the hardware to make sure that that is the Android operating system that's booting up. Right, so working with the hardware manufacturers, some of the hardware manufacturers added their own additional layers of hardware security, but the operating system allowed for this. And then as you got into 7 and 8, starting to build Google's own version of the phone, Pixel, which took their highest standards of security, and then adding network layers of security, and then also adding biometrics as well, so having multi-factor authentication, having factors of authentication into the work profile, having factors of authentication into the phone, making it more secure, difficult for hackers to try to get in, enforcing encryption as well. And then they did something to allow, from a security perspective, updates every month. So rather than refreshing the OS through the carriers every time there's a new security breach, they were allowed to easily quickly find the new attacks, quickly push updates through a monthly security patch. Right? So this is just very similar to what we do today as a CISO and security team. We want the phones to be updated with against the latest and greatest types of attacks. And then continuing all the way to 8, adding some network layers of security as well, and starting to think about these other types of attack surfaces, and making sure that the device is locked and secured, adding additional protection from a rooting kit. We're looking for low-level types of attacks or kernel privilege escalations, right? So adding, again, more layers, working with the hardware and the software together to create, a secure mobile operating system. So as we look at the modern operating systems on the mobile devices today, we see Android 8.0, iOS 11, massive improvement from the Android 4.4 as we discussed in the previous question. Some of the highlights that are key here are application updates, the way they happen on Android. So from a security perspective, this is good, right? So as the developers find risks in their platform or things are discovered, they can go update that and it's automatically downloaded in the background. And then also looking from that possible malicious attack where a good developer actually starts becoming bad possibly and asking for additional permissions and things like that on the background after you've already installed the app, right? So thinking about that flashlight app that all of a sudden requests access to your contact information. Well, the flashlight doesn't need that. So the Android operating system starts looking at, as it's running, as it starts up, what permissions are being asked for, and allows the end user to sit there and say, no, I don't want that. Or then, as it's running, if something tries to change in the background as well. And then you start looking at some of the other improvements they've had. Biometric capabilities have definitely been growing on all these devices, but multiple biometric capabilities, especially as you talk about that, the Android container and being able to factor authentication into the different parts of the phone with maybe fingerprint to get into your device, your iris to get, into your work site as well. So that's built in to the Android operating system now. And then we look at some of the network-based attacks. When you walk into a coffee shop, an airport, how do I know that I'm on that Wi-Fi that's real? Well, so the Android operating system has added enhancements into the network security protection stack, looking for some of the most common types of malicious attacks, so you're not on a malicious Wi-Fi. And then we start looking at, we talked about the security update, but that's becoming really important, the monthly security updates, and that's on by default. So as an end user, I'm going to start getting pop-ups saying, hey, there's a security update, let's install that, right? So that's also important. And then we look at that hardware-software kernel protection, right? So that real-time kernel protection. So not only at this beginning as that phone starts up, but I also want to look at it as it's running. So I'm installing applications, I'm getting SMSs, I'm browsing the web, all this other stuff. I'm also wanting continuous kernel protection. And then if you start going into the Pixel and the Pixel 2 and the Samsung Knox, they've added additional built-in capabilities on top of all this as well. So like one example is jailbreaking and rooting. So jailbreaking is on iOS, rooting is on Android. Right? So today we still have, all the way to iOS 11, there's still jailbreaks available. the equivalent on Android is rooting. But then, companies like Google and Samsung have added additional capabilities above and beyond the Android security standard to add more layers of protection to try to reduce the risk of rooting. And then we look at browsing as well, like I mentioned earlier, right? So thinking about on the desktop, there was all these browser attacks, and the desktop, browsers have started to reduce things, but the Android was built from the ground up with that. And so is iOS, but Android has now hardened things, looked at the versions of the SSL that they built into the browsing capabilities. They've disabled Flash, so they've really hardened the browsing. So some of the traditional desktop attacks wouldn't work on that mobile device. And now we look at, once the users brought it into the corporation to kind of start getting it managed, they join the MDM or the EMM, which is a mobile device management or the enterprise mobility management tool, and now the corporation starts managing the corporate side of the device. Android's done a lot of work in bringing a lot of configurations that the enterprise can control. As an example, we talked about there's the consumer side and the work profile and then the container side. So being able to lock that down, making sure that I have multiple types of authentication. Maybe I'm going to require a fingerprint or a passcode or logging into a corporate directory as well that separates that. So if that phone goes to your son or your daughter, they're going to, yes, they can play the games on it, but they're going to be locked out of the corporate file system in the corporate container. And so we see that delineation is very key over for iOS, right? So on iOS, you have to have it managed through some kind of DEP program, and you still don't get the flexibility of true segregation like Android has done with the Android Enterprise. And then companies like Samsung Knox have built that hardened Knox container on top of that. And then, so this isolation is critical to IT organizations. And not only, now that I have it separated, I could then control it and wipe it. So you call me, you've lost your phone in the airport, not only could I wipe the phone, but I could also just wipe the corporate side, right? So I'm protecting the enterprise side. So a lot of individuals, like that, yes, it's separated. They can't see my personal stuff. They're going to manage the corporate side of this. And then we start, looking at the remote health attestation as well. We talked about that the phone tries to make sure that it's the right operating system that boots up with the TE and all the other things we talked about. But now I could also then go to a remote site and see if that device is actually, the OS hasn't been tampered with at all as it's running, as we talked about that kernel integrity protection. And then, so from a corporate perspective, I'm more secure saying that this is the right phone on the right hardware, it's being managed, it's being secured, my enterprise data is locked away and secured. So we've been doing this all-up study, both the, what's built into the operating system and now what's being managed by the corporation as well. And we've been doing this for many years now, and we've seen the growth of Android. When we first started off, there was a lot of weak and average kind of features when it came to these security things. As they've grown from Android 4 up to Android Enterprise and the Samsung Knoxes and the Pixels, we've seen them grow to a lot of strong in the category. So they've taken the focus of just consumer to really investing into the security ramifications and becoming a very strong competitor in the security space on mobile devices. We do year-over-year research on this question, and we have a minimum recommendation. And currently, we're set at Android 6.0 with the latest security patches. There's other forms of these devices that are exceeding the minimum standard that we're recommending, but don't allow any device under that into your enterprise. But for devices like the Pixel 2, the Samsung, and some of these other ones we've discussed, they exceed these standards. And now Google has also rolled out a new program that's called Android Enterprise Recommended. So they've been working with some of these hardware manufacturers that are going to allow them to ensure that these new raised standards above and beyond the CDD are met, and they also will be getting the security patches in a very timely manner. Right? So these are another set of devices that will be great for your enterprise because they'll have the latest and greatest security updates on them. Well, you think about it, Android is the predominant mobile device out there on the planet today. And with the Google Play Protect service that they've built, it allows them to have access to what's going on real time in this. Or if there's a malicious application that's being spread, If someone's trying to do some kind of a targeted-based attack at a particular country, that Google Play Protect service gives them that visibility. They see what's going on the devices. They have their machine learning backend. They do static and dynamic analysis for these updates. And then not only if it's tried to be deployed to the Google Play Store, but even third-party stores, they will see that and then be able to respond to that. So think about that. The attacker comes in, tries to spread some kind of ransomware in a country. They see that because they've tried, it's been sideloaded, they automatically see it, then they remove it from that device in real time. So this gives them a huge, competitive advantage from a security perspective.
The foundations of Android security can be looked at in two dimensions, the technical aspects and then the philosophical aspects. On the technical side, it's the base operating system security, it's Play Protect, the mobile security services, and it's the Android security development lifecycle. How do we create a consistent level of quality across the ecosystem through testing and so forth? On the philosophical side, it's really about transparency and measurability. So things like the Google Transparency Report, the Year in Review, these are all making sure that the ecosystem understands where the threats are emerging and what we're doing to correct them and how we're actually doing in response to those. And measurability is really important, using data to help drive our resource investments in the right direction. And we also look for ways of getting independent assurance. So the Gartner Comparison Report is a good example of having that independent assessment that helps inform our actions. How has it evolved over the past couple of years? A couple of key focus areas in each of the technical areas. On the operating system side, really locking down permissions and APIs. We're constantly watching that and looking how we can make that better. Leveraging hardware protection, so not just in things like verified boot, but enabling developers to actually leverage some of those hardware capabilities. And anti-exploitation, which means vulnerabilities are going to happen on every popular platform, but those vulnerabilities do not have to translate into exploits that actually harm users and enterprises. So things like ASLR, control flow integrity protection, these are all techniques, really cutting edge research techniques that we're applying in Android to enable or to ensure that the system will not be exploited even in the midst of vulnerabilities. On the Play Protect side, applying machine learning. This enables us to really scale to the emerging threats and to detect threats in real time. Working more closely with third-party security partners, that's really important. We have great relationships. We want to double down on that and really leverage their knowledge and their expertise to make Play Protect and Android security better overall. And finally, on the security development lifecycle part of things, there are really two main focus areas over the past couple of years. One is expanding our testing, both deep and wide. So not just APIs and frameworks, but testing down into the kernel and into the hardware, all across an Android device. And really, in terms of wide testing, it's investing in different kinds of testing, like fuzzing infrastructure. Fuzzing is the way that attackers actually look for exploitable vulnerabilities. We've invested in fuzzing so that we can find them before anyone else does. And finally, of course, security patching is very important, a tremendous focus of Google. And it's not just on the technical side. How do we make patching just easier to adopt with projects like Treble for more modularity that just make it easier to take in patches and deploy them? But it's also in the processes we follow. So for example, we've included security patching into our OEM agreements, and that's really going to continue to accelerate a patch availability across devices. We had 1 billion devices or so patched in 2017. We think that those OEM agreements are going to really accelerate the availability of patches across more devices. So I think probably the two most obvious unique attributes for Google in security is scale and computer science. On the scale side, you look at Google's over-the-air update system. Most device manufacturers are leveraging that worldwide. There's updates going out every single day, probably every single minute. And so getting that kind of scale across the Google Cloud obviously enables that kind of scale and the overall computing resources and connectivity. Also, the Play Protect itself, Google Play Protect, it's running on over 2 billion devices now. It's the world's most widely deployed operating system threat detection solution, to the best of my knowledge. That kind of scale, 50 billion app verifications performed each day, that is really definitely a unique aspect of Google. I think on the computer science side, obviously we have great research on security throughout the company, but I think the real special sauce there is applying it to solve practical problems. And again, machine learning is a good example of that. We work with the Google Brain team, the DeepMind team, and take the sort of research knowledge and apply it to the problem. We actually reported in our most recent year in review that 60% of threats are currently being detected through machine learning. And that's really quite astounding given we only started doing that kind of thing in the past couple of years. So another aspect of the scale that I think is really important is just the people. We often talk about the technology at Google, but it's the people. Our team that looks over security for Android, Play, and Chrome OS is just one of many teams at Google Security. We have people who look over account protection, identity platforms, internal corporate security. They're super demanding, and they drive us to a very high standard, which is excellent. We have people in cloud security, of course, and so on and so forth. There are thousands of people that contribute to mobile security at Google, and so I think the scale and the computer science are probably the two most obvious attributes that we bring to the table there. Well, I think the Gartner Mobile Security Comparison Report speaks to that quite well, actually. Covers a wide range of concerns that enterprises have. And I've worked with Gartner for quite some time, many years. The research analysts at Gartner, when they make these comparisons, it's based on their own technical knowledge, as well as the input from a wide range of enterprise customers who have specific requirements and can tell the analysts how solutions are working for them. And so when people look at this report, they'll see just how far Android has come in really achieving a much higher level of security in Android. We also have worked with consumer independent research companies. Recently, we worked with one that did a global survey across 10 different geographies, asking the question, do you feel confident? Do you feel that Android devices are secure? And what we found was, on average, 2/3 of consumers agreed with that devices are secure. And that was actually on par with other mobile devices. And so I think that really, again, speaks to the overall both enterprise and consumer improvements in consumer sentiment. Anecdotally, there's a lot of positive coverage recently. If you look at the response to some of these very, very high-profile cross-platform vulnerabilities like Spectre, Meltdown, Blueborn, Crack that affect multiple operating systems, there's been a lot of positive coverage about Android really delivering patches very fast, on time, in advance of public disclosure. So I think these things all contribute to positive security sentiment. So when you talk about open versus closed platforms, I think sometimes people mistake that question as a question about open source versus closed source. And one of the things we've learned over the past couple of years is hackers don't need the source code to make attacks and to exploit systems. We've seen a lot of very high-profile exploits in closed source platforms in the last couple of years. And so really the question is about the open ecosystem. That's the true power that brings to bear in the security realm. And in particular, if you look at how trends are going in security, attackers are getting much more sophisticated, they're well-resourced, they're determined to do harm. And we need the best defense against that. On a closed platform, you have a single company and its resources, and even companies like Google, at some level, we're limited in what we can do. And so in Android, it's all about the ecosystem. So you have device manufacturers with tremendous security teams all working every day on Android security. You have the microprocessor manufacturers, ARM, Intel, Qualcomm, Broadcom, and so forth, also with fantastic security teams contributing to Android security. You have the Linux open source community. You have the academic world. Academicians like to work on open source and open platforms. And so it's kind of this massive multiplier of a protective defense against attackers on Android. And so I think, again, in 2017, we've seen the exploitability rise, the difficulty rise to a point of parity. I think it's the power of open that's going to cause that difference to really accelerate into the future. Well, let's go back to the Gartner Mobile Security Comparison Report. It covers a lot of ground. There are a couple of dozen categories for everything from the ability of the operating system to protect itself, network security, secure browsing, these are all areas where Android security really does well. The work profile is something that's really unique to Android and very important for enterprises. What that means is it adds a second layer of defense. So all of the enterprise apps and data are securely isolated above the normal sandboxing of the operating system from the personal side and the personal apps and data. And that gives users a tremendous confidence in their personal privacy, while simultaneously giving businesses the confidence they need that their data and their networks are being protected. And so on top of those capabilities, app monitoring and control, another really critical feature that's listed in the security comparison report. And what that means is malware affects all major platforms. And in order to defend against phishing attacks, the typical things that enterprises face every day, you need to have the malware protection, the threat detection built into the operating system. And that's, of course, what Google Play Protect does for Android. And finally, I think device diversity is really important. Diversity is strength, and that gives enterprises more choice at different price points, a lower total cost of ownership, and also makes Android actually more difficult to exploit. So these are all things that contribute to why Android is a fantastic choice for enterprises today.